This is 3-5 on slope. We're working under the Big Ideas book, page 141, 1 through 24 all. Alright, so let's get started. So far what we've learned is how to graph a line using tables. Now, the one thing to think about is when you are graphing, remember all your points that you chose may not fit. So it doesn't mean you have to plot them all. You only need 3 points to plot a line. So you plot what you can. The more you do, the more accurate the line will be. Remember, the line should always run through the sides of the graph and cross the X and Y axis. Make sure and label your X and Y axis, and make sure you always put arrows on the ends of your axes as well as the line. Now, for the purpose of the PowerPoint, there may be times where it's left off. That is because I did not make these. And due to the PowerPoint, it's hard for me to manipulate that. But in terms of you guys, I expect you to label and put arrows on all lines and use straight edge. Alright, so when we're dealing with a table like this, when we talk about slope, what we're really talking about is how steep is that line. So the equation for this line is y equals 2x minus 3. And when we're talking about the slope of the line, we like to use the variable m. What we're really talking about is your vertical change over horizontal change. Or another way to write that is your change in your y over your change in your x. Or we can also say it's a rise over run. Now, the way we find the slope is we start at a point and we count how many units we can rise. That's a vertical movement. How many we can rise to the next point vertically, either up or down, over, and then how many we run across. So it's 1 unit across, and that's what I would put as my run in the denominator. So this slope is 2 over 1. I can take any 2 points, basically, any 2 points. I could go from here and go all the way down to, sorry, I'm using my finger here. And so we can count units. I've got 1 unit, 2 units, 3 units, 4 units. Oops. 4 units. 4 units down. And since I'm going down, it's going to be -4. And then it's 1, 2 units over, -2. Now the thing to remember is that X and Y axis is really 2 different number lines. And so we've got a number line here and a number line here. When I move to the left, I'm moving in a negative direction. When I move to the right, I'm moving in a positive direction. When I move down, I'm moving negative because the numbers get down lower on the number line. And when I move up, it's a positive. So you need to reflect that when you are looking for your slope. So when I look at my rise over run there, and we found that it's -4 over -2, this basically reduces to the same thing, 2, because a negative divided by a negative is a positive. So you can pick any 2 points. Now if you happen to do your across first, remember, that's a run. A horizontal movement goes under the denominator. -2 would go under the denominator, and then I go down 4. But that up and down is the change in the y. That's the vertical movement that would go in the numerator. So just make sure you set it up correctly. Now, let's talk a little bit about this equation. You will notice my slope is 2. And where do you find that in the equation? It's right before the x. The m in the equation is the coefficient of x. So the general formula for slope-intercept is y equals mx plus b, where m is your slope and b is your y-intercept. So in this case, 2 is my slope. 2 is the slope, and -3 is the y-intercept. And you will notice that the y-intercept is where the line crosses the y-axis. So where does our line cross the y-axis? That's called the y-intercept. Okay, let's move on. Let's start with the easiest way to find the slope. The way we find the slope is the easiest thing. If given a graph, is check for your rise over run. So to get from one point to the next, we know that if I go from this first point, I'm going a rise of 1, and I'm going to run 1, 2, 3, positive 3. And this reduces to 1 over 3. Now it doesn't really matter. I could have used, how about -1? My rise is a -1, and then running 1, 2, 3 over -3. It still reduces to the same thing. So any 2 points, it does not matter. All right. Now, try the next one on your own. Now check your work. We're going to rise 3 and run 2. Hopefully you got +3 over +2. Now, let's try one more. Now check your work. I'm going to rise -1 because I'm going in the downward direction. And then I'm running +1, 2, 3, 4. So it's -1 over +4 reduces to -1/4. If you have only one negative, it should be a negative slope. Another way you can think of slope to check yourself is we read a graph from left to right. So think about your line like it's money. In this graph, you see that your money starts high and it gradually decreases. You don't want that line for you to represent your money. Whereas if we go to the other graph, starting from the left, it starts low and rises quickly. That's how we want to see our money growing. Okay, so that's a positive slope. The other one was a positive slope. It's growing in a positive direction. This one is declining, so that would be a negative slope. All right, try another one. Now check your work. Now try one more. Now check yourself. And if you can reduce it, make sure to reduce it. All right, I'm going to skip forward and let's move on to how to find slope given 2 points algebraically. Usually we would use this if given a table or given a set of ordered pairs. So you take any 2 points. In this case, we're going to take the 2 that have been listed, and you have to first of all name them. Let's call one 0.1 and the other one 0.2. Okay. So what that means when I call it 0.1 is x1, whoops, let me go to my blue. We've got x1, comma y1, and we've got x2, y2. So the slope formula is as follows. M equals, don't leave out the M. You don't need to write the word slope. M equals y2 minus y1 over x2 minus x1. That means I'm going to take the second y2 and I'm going to subtract, because there's a subtraction sign, and subtract the first one, -3. put it over the first x, which is 1, minus the first x. Sorry, the second x minus the first x, negative 2. And then I'm going to simplify it, and I get m is equal to 5 over 3. And it's a positive over a positive. And there's my slope using slope formula. Now let's try it together. So, find the slope between the 2 points. Step 1, just a reminder, we're going to name the points. Here's point 1, here's point 2. That means this is x1, y1, x2, y2. Another way to call that is x sub 1 and y sub 1, but we can just say x1, y1. And now we're going to do our slope formula. We always write the formula. Please do not just write it once. M equals y. y2 minus y1 over x2 is x1. M equals 7 minus 3 over x2 is 4 minus negative 1. M equals 4 over 5. Okay, and so here we have our slope. Now you try it. You've got your notes, refer to your notes, and try it with the next 2 points. You will notice that every time we do this, I write the slope formula every time. You must do that. So, start with your slope formula, and let's find slope. Now check your work. Start with the slope formula, y2 minus y1 over x2 minus x1. Now substitute in. And you should have gotten m equals negative 2 over 7. I want to remind you, we want to reduce this every time if it can be reduced. How about trying it again? Now check your work. And you will notice that m, I'm reducing it to the smallest fraction I can. All right, so if I've got a horizontal line, y equals 2, let's take a look at that slope. We can take any point on that slope. Let me have if we prove that. Okay, we can take any point on that slope. Today, let's take this one and this point. So the first point is 1, 1, 2. And the other point is 2, 2. If I do the slope formula and I do 2 minus 2, y2 minus y1 over x2 minus x1, you will get 2 minus 2 over 2 minus 1, and which is 0 over 1, which equals 0. So here, my m is equal to 0. If I do the same thing here, so the first point is negative 3, 0. And the other point is negative 3, 1. Okay. And we do our 0 minus 1 over negative 3 minus negative 3. You will see we get negative 1 over 0. And in this situation, we get a 0 in the denominator, and that's what we say is undefined. Okay, pause it, take your notes, And then let's move on to the next step. All right. Let's see if we can get to... So for all horizontal lines, the slope will be 0. We call that a flat slope. But for all vertical lines, it will always be undefined, which we just proved. Okay. I want to add one more thing that's showing up in your homework tonight. Now, let's say we get an equation like this. Y equals 3x minus 2. So I mentioned before that the first part, the number that precedes the x is called our slope. And this -2 is what the y-intercept. It's where the line crosses the y-axis. And the x and y, really, that's your ordered pair. So, if I give you the equation y equals -5x minus 2, what would your slope be and what would your y-intercept be? Well, we use the m to represent slope, and we know that the slope is the coefficient of x, so it would be -5. And we said b, remember earlier I gave you the equation? Y equals mx plus b. Let me do that in blue. Y equals mx plus b. Actually, let's move on. Y equals mx plus b. So in y equals -5x minus 2, we know that our m is our slope, and that would be -5. The number that precedes the x, the coefficient of x, and my b is the constant term. So that would be -2. All right, let's try another. Y equals 1/2 x plus 3. All right, let's identify your m and your b, your slope and your y-intercept. Okay. How about if we try it the other way around? What if I give you an m of 3 and a b of 2? Well, remember, we start with y equals mx plus b. Y equals 3. X stays the same, and the b is a positive 2. So now I've written the linear equation. All right, now, how about the exception? What happens if I have y equals 3x? My m would be, that's right, 3. But my b would be plus what? It's plus zeros. So I don't need to write plus 0. If nothing is there, I just post a 0. All right, so that's all we've learned for today, and we will go over it some more tomorrow.